everyone, and welcome to the last lesson of Unit 3, Lesson 20.2, which starts on page 270 in your Springboard books. On page 270, we see one of our favorite vocab words from Unit 3, reference angle, officially being defined. And we've talked a lot about reference angles so far, so it's kind of wild that they haven't talked about it until this lesson. But we know that reference angle is the quadrant 1 value. And then in order to find the quadrants 2, 3, and 4 value, we're basically looking at different parts of either 180 minus theta, 180 plus theta, or 360 minus theta when we're talking like in our degrees mode versus pies instead of 180 and 2 pi instead of 360 for radians. So this is in your book, although I really like this handy dandy diagram that's on here. I think it's a helpful thing to kind of have in your notes because basically throughout this, when we're thinking of solving these equations, we really are just mindful of, okay, what's my quadrant 1 value? And then what are the other places it's either positive or negative, perhaps? And again, knowing that reference angle can then just kind of help you find the other values around the circle, both for unit circle values that we know exact answers of and using approximations in our calculator, which we will do today. So again, they're talking a lot here about what those reference angles are given a measurement and then plugging that in there. So all that examples on page 270. Another example we see on page 270 in the Springboard book is a little more work with our trig equations. Now, again, when we're solving these trig equations, so far we've only looked at equations that are exact values from the unit circle. We know there are other values around the circle that are not our exact values, though. So our calculator can help us approximate those values. Now, once again, our reference angles are going to be helpful to us and thinking about where things are positive and negative. So we know that cosine is positive in quadrants 1 and 4. So we find that reference angle, which is also the quadrant 1 angle, and then also subtract from 360 to get the quadrant 4 value there. Example B, that is on page 271, gives an example in radians. And we know it's radians versus degrees because they're telling us 0 to 2 pi, unlike the first example that said 0 to 360. So we know what mode our calculator is in. Again, be very careful of that. Now, this time when we start solving this equation, what we find is that we get sine in a negative situation. And we know sine is negative in 2 places, in quadrant 3 and quadrant 4. So when we type this in, we get the quadrant 1 value as our reference angle is, in this case, 0.201 radian. And then that's actually not one of our answers because, again, we want where this is negative, not positive. So we need to subtract from 2 pi to get the quadrant 4 value and add 2 pi to get the quadrant 3 value. So these are actually our only 2 values. We just use that quadrant 1 value to help us find those values. Now, some of you may be thinking, why didn't you just type this into the calculator? And you totally could. But remember, your calculator is going to give you that quadrant 4 answer, or negative quadrant 1, as I like to call it, answer. It would have given you negative 0.201. And again, this is not in our domain. So this is not an acceptable answer. This is an acceptable way to use to help us find these. You could have added 2 pi to this to find the coterminal, which would have actually been this. But again, finding that quadrant 1 reference angle is usually the easier route to go to find these values down here, okay? Now, some of these other examples that we have here, as we start solving to isolate our sine, we need to subtract the 4 and divide by 5 so that we get sine equal to 3/5. Now, fair warning, they don't give you a ton of room to write here, so you might want to write very small and write this in the My Notes section of your book. But again, we're going to have to approximate this value because 3/5 is not a value we find anywhere on that unit circle. And we're going to be using degrees. So we're going to make sure our mode is in degrees before we get started, since they're telling us to look for intervals from 0 to 360. So sine inverse of 3/5 gives us a lovely reference angle of 36.9, since it's a tenth of the degree, as our reference angle. Okay. Now, sine is going to be positive, right? And we know sine is positive in quadrants 1 and 2. So that's where our answers are coming from, quadrants 1 and 2. So 36.9 was the quadrant 1 value. We have to take 180 minus that reference angle to get our quadrant 2 value, which is 143.1 degrees. Okay, so our two answers here, 36.9 degrees and 143.1 degrees. Cotangent then, if we start solving for part B, add the two, we end up with -5. And a reminder, since cotangent isn't on our calculator, we can use the reciprocal, so 1/5, in order to actually type this in our calculator. So we would take tan inverse this time of -1/5. And notice again, this is giving us that quadrant 4 value. So you can either use this, or again, a lot of times what we like to do is just find that quadrant 1 value, because that's our reference angle. Or if you type this in, understand this will always be the positive of that is your reference angle, the 11.3. So again, reference angle here is 11.3 degrees. So we know tangent, however, is negative in two quadrants, 2 and 4. So one of those is going to be the quadrant 4 value. Now again, negative 11.3 degrees does not fall in our interval. So instead, we have to use that reference angle, and we would take 180 minus 11.3, 180 minus 11.3 would give us quadrant 2, and 360 minus 11.3 would give us 348.7. So our two values then for theta are going to be the 168.7 degrees from quadrant 2 and quadrant 4. Now, the next couple of examples here, they instead use for us the radian measure. So we're going to take this moment to make sure we change our calculator over to radian. And from there, we see on this one, they have everything mostly isolated, but we need to make sure we now square root. And in this case, reminder, when you square root, it's plus or minus the square root of 1 over 16, which we know is actually 1 over 4. When we break up the party and do each of these individually, square root of 1 is 1, square root of 16 is 4. Okay? Now, again, not a unit circle value that we know of. So if we take cosine inverse of 1/4, we get our reference value of 1.318 radians. For whatever reason, they want us to round those to the nearest thousandth, so 3 decimal places there. So x, again, after we take cosine inverse of 1 over 4, we get the 1.318, okay? That's, again, think reference angle. And since it's plus or minus, actually our answers are coming from all 4 quadrants, okay? And so one of our answers then for x will be the quadrant 1 answer, and then pi minus 1.318. We have pi plus 1.318 and 2 pi minus 1.318. Gives us our other 3 remaining values, okay? So they're not super pretty to write out because they're, again, for whatever reason, wanting us to use 3 decimal places. And again, though, we know our answers when it comes to radians will need to fall somewhere between 0 and 6.5 0.28 if it's going to be 0 and 2 pi are approximations here. So those do make sense, one from each quadrant. Our last example of today is dealing with letter D here. And if we start, we have 6 cosecant of x, and then we subtract over the 9, divide by the 6. We know that this reduces really to be -3/2. Well, again, cosecant, not a button we have on our calculator, so what we can do instead is turn this into the reciprocal function. And then look at sine inverse. Again, I would just use the first quadrant value to find that lovely reference angle. In this case, sine inverse of 2/3 is 0.730 because we're rounding up the 9 up to 2, so 0.730. Okay. Now, again, sine is negative, however, and we know sine is negative in quadrants 3 and 4. So we're not really looking for here this value. This is not going to be included in our answers. Instead, what we need to do is take pi plus the 0.730 to get quadrant 3, and 2 pi minus the 0.73 to get our other answer, right? To get our final answers here of pi plus, which would be 3.872, and then 2 pi minus, which is 5.553. Again, our values coming between 0 and 2 pi because of, approximation of 2 pi being 6.28. Okay. We will definitely be working more with some examples in class. Thanks everyone for watching, and congrats on finally making it to the end of our unit. Some things to definitely consider looking at is having some steps to write down in your notes, and I would definitely remember the ways to find your reference angles in case you've forgotten from before break as well.